Okay, hello children. Today's notes are 6-5 operations with radical expressions. I think we're going to do the multiplication, addition, and subtraction, and then I'll leave division for day 2, but we'll see how it goes. So our first example, multiplication. To do multiplication, your index needs to be the same, so same index. And you see here that the index is 3 for both of them. We're going to multiply outside times the outside and inside times inside. But really, I'm not going to do this part. I'm not going to do the inside part because I don't want to make this number bigger because we're trying to simplify. But the 5 and the 3, we're definitely going to make that into 15. It's still going to be cubed root. I'm just going to put both of these underneath here. 12ab to the 4th times 18a squared b squared. And then I'm going to break down this negative 12, but I'm also going to take out the negative. Since this is a cube root, that's the cube root of negative 1, and then I'll divide this into the cube root of positive 12 ab to the 4th times, all right, sorry about that. So now I have 18a squared b squared as well. Now the reason why I'm not actually multiplying this because there would be no point. I want to make pairs, so if I made this number bigger by multiplying them, I would only have to break them down like we did yesterday. So 12, we're going to divide the 12 by 2, we get 6. Divide that by 2, we get 3. Divide 3 by 3, we get 1. Okay, with 18, going to do the same thing. I can divide it by 2 and get 9. 9 will have to be by 3 and get 3, and then 3 and 1. Now I can choose pairs from here or here. So this 2 and this 2 could be a pair. I already have a 15. The cube root of negative 1 is negative 1. And then I have a pair of 2's, so 2. 15 times negative 1 times 2. And then I also have a pair of 3's here, so I could take whichever pair. It does not matter. So a pair of 3's. So I use this 2, these 3's, and then I have a 2 and a 3 left. Now it was a cube root. Whoops, it was a cube root. Let's start. Sorry, cube root. So 2, 2, and this 2 make 1, 2. 15, negative 1, 1 pair of 2's. I need 3 of them. And then 3, 3, and 3, a 3. Okay, so I actually used all of the numbers. Now for the A's, I have 1 here and 2 here. That means I can make 1 group of A's and none left because that's a total of 3. 4, 5, 6 B's. To make a group of 3, I would be able to make 2. 3 times 2, that would be 6. So now I don't have anything left underneath the radical. I'm just going to multiply all of this together to figure out what it is simplified to. So 15 times 2 times 3, that's 90. So then negative 1 would be negative 90, ab squared. All right, there we go. I'm glad I caught that cube root in time. So here we go. Cube root right here. Okay. So now go ahead and pause the video here. Try this one on your own. And then check your answer. Okay, so this should have been your answer. Go ahead and check your work if you did not get this answer. Let me know tomorrow. Okay, so now let's go to adding and subtracting. In order to add or subtract radicals, the radicals must be like terms. Radicals are like terms if both the index and the radicand are identical. So like, for example, this. These are like terms. There are an index of 2, and the radicand is 3b. It could also be the cubed root of 4a squared and -2 cubed root of 4a squared. So these are examples of like term. If either one of these is not the same, if the index is different, or if the radicand is different, then they would not be like terms, and you would not be able to add or subtract them to combine. Okay, so here's a subtraction. We're subtracting the square root of 98 minus 2 times the square root of 32. So the index is the same, it's 2 and 2, but the radicand is different. But are these simplified? I think not. So we're going to simplify 98 like we have been doing. So we can divide 98 by 2 and get 49. 49 no longer divisible by 2. Move on to 3, not divisible by 3, not divisible by 5, divisible by 7. 7 times 7 is 49. And then 7 we can divide by 7 and get 1. Okay? Then we'll also do the same thing with 32. Now 32 has a 2 on the outside. So I'm going to write that 2 and then put a times. This square root of 98, I made a pair of 7s since the index is 2. I have a pair of 7s. So 7 and it's a square root, the 2 is left over. Minus, now I have a 2 here, times, we're going to do the same thing with 32. So we're divided by 2, we have 16. Divide that by 2, 8, 2, 4, 2, 2, 2, 1. So now here I have a 2 already, and then I have another 2, and a 2 left over. So 2 times 2 times 2, that is 8 square roots of 2. Now the radical, the index is the same, they're both square roots, and the radicand is also the same, they're both square roots of 2. What you do in this case is you just look at the outside numbers. 7 minus 8 is -1, and keep the radicand the same. So -1 square root of 2, or simply just negative square root of 2. So once you get those to be the same, all you do is add or subtract the outside numbers. Okay? If you want to pause the video here and try this one on your own, feel free. Okay, so for this one, I simplified 5 squared root of 12. I put the 5 on the outside, broke down 12 into the prime numbers. I had a pair of 2's, and then that 2 gets multiplied with the 5 to make 10. Same thing here with the 2 squared root of 27. I put the 2 on the outside, broke down 27, had a pair of 3's. 3 times the 2 would make 6 square roots of 3. Then the square root of 128 doesn't have a number on the outside, so I just broke down 128. There happen to be 3 pairs of 2's, so that's 2 times 2 times 2, and a square root of 2 left, so 8 square root of 2. Now, in order to add or subtract, we need the same index and the same radicand. So here, the radicand is 2, the index is 2, 2 and 2, all square roots. The radicand is 3, 3 and 2. So I can combine these two, but I cannot combine this one with these. 10 square root of 3 plus 6 square root of 3 is going to be 16 square roots of 3. And then the only thing I can do with this is just write it behind. So there we go. Okay. And that's the most simplified way to write the answer. Okay, let's go to multiplication but distribution. So with this, we're going to do the same thing that we did with our box method. 4 square root of 3 plus 5 square root of 2. We're going to multiply that using our box. We're going to do 3 square root of 2 minus 6. And then I'm going to multiply to fill in all of the boxes here. Number times number on the outside, so 12. Square root 2 times 3 is 6. 3 and 5 make 15. Square root of 2 times square root of 2 is 4. Negative 6 and 4 is negative 24. Square root of 3. And then this would be negative 30 square root of 2. Now I need to simplify, so (12) square root of 6 plus 15 square root of 4 minus 24 square roots of 3 minus 30 square roots of 2. I know these for sure I cannot break down any further because 3 is prime and so is 2. What is not prime is the square root of 4. The square root of 4 is 2. So really this is 15 times the number 2. For the square root of 6, if I break down 6, divide that by 2, I get 3. And then 3 divided by 3 is 1, and then there's no pairs. So this stays 12 square root of 6 plus, this happens to be 30 minus 24 square root of 3 minus 30 square root of 2. So I can't really combine anything, but I was able to simplify the square root of 4 into just the number 2. Not square root of 2, but 2. And this becomes 30 plus 12 square root of 6 minus 24 square root of 3 minus 30 square root of 2. All the radicands have the same index, but none of the radicands are similar, are the same, are identical. So there's that. And that's the simplest way to write that answer. There's nothing more we can do there. Okay? There we go. Okay. Go ahead and pause the video and you give this one a try. All right, so I went ahead and made my box, multiplied everything out together. I end up with this. So 49 square root of 4. The square root of 4 is 2. We know that. It's a perfect square, so I'm just going to change that to a 2. Negative 21 square root of 6. And we already tried to break down 6 in the previous example. 6 doesn't break down into anything besides 3 and 2, so there's no pairs. Plus 21 square root of 6. Now these two are the same, so I can combine them, but one's positive, one's negative, so they really just cancel each other out. And then minus 9 square root of 9. And square root of 9 is 3, so this is just really negative 9 times 3. Okay. So then we have 49 times 2, that's going to give us 98, minus 9 times 3, so 27. And these just happen to be whole numbers now. We got rid of the radical, so then 98 minus 27 is then going to be 71. Okay, yep, that's all we're going to do today. So we multiplied, we did distributing with the box, and then we also did addition and subtraction. For multiplication, multiply the outside times outside, inside times inside. Sometimes you don't really want to do the inside times inside. If it makes the number a lot bigger, we don't want to do that. And then when adding and subtracting, all you need is to add or subtract the outside numbers, and the radicand needs to be the same, and the index also needs to be the same. Okay, see you tomorrow. Bye.